Okay, here's number 22. P1, P2, P3 is an isosceles triangle where P1, P3, the length of P1, P3 is square root of 3 times P1, P2. And O is an origin such that OP is Z1 and vector OP2 is Z2 and vector OP3 is Z3. Suppose the argument Z1 minus Z2 minus Z1 is alpha. Show that the argument Z3 minus Z2 is alpha minus pi over 3. And hence find the modulus and the argument of Z2 minus Z1 over Z3 minus Z2. So, let's just draw a line perpendicular to P1 and P3 in this case. It's really up to you where you draw the origin, but I just want to make things simpler. So let's say here is the origin. Then let's change the color of this thing. Then from O to P1, that's vector Z1. And then O to P2 is vector Z2. And then O to P3 is vector Z3. So Z1, Z2, and then Z3. And here, we know that vector Z2 minus Z1, which is minus Z1 plus Z2. So in this case, this becomes the initial point and that becomes the final point. So this is same thing as vector P1, P2. So here, since we drew the x-axis perpendicular to P1, P3, then if you move this vector P1, P2 to this point, that angle should be exactly same as this angle. So this angle can be called alpha. And then here, show that the argument of Z3 minus Z2. Z3 minus Z2, which is minus Z2 plus Z3. Then in that case, P2 becomes the initial point and then P3 becomes the final point. So this represents the vector P2 to P3. Vector P2 and then P3. So here I'm going to draw another parallel line to both x-axis and P1 and P3, which passes through the P2 right there. Then we know that since this triangle is isosceles, we know that this is alpha, and then also since these two lines are parallel, this is also alpha. And let me just draw a perpendicular line to P1 and P3 from P2. And since this is isosceles, this perpendicular line bisects the P1 and P3. So which means if this is x, that should be the x, and then this should be the whole thing, P1, P3 should be square root of 3 x. But then we divide this by half. This half part, let's say this is m. M to P3 becomes square root of 3 over 2x. If this is x and if this is square root of 3 over 2, then this must be 1/2 x. This is special right triangle, 30, 60, 90. So in that case, this must be 60 degrees and this must be 30 degrees. So alpha is 30 degrees. And the thing is, here, the vector Z3 minus Z2 is represented by P2, P3. Then if you move this line to here, the angle formed by the x-axis and this P2, P3 is exactly same as here, but we knew that this was alpha. And the thing is, since we measure the angle from angle in clockwise, this must be 30 degrees but minus 30 degrees or minus pi over 6. We know, and alpha, since we are measuring counterclockwise, alpha is pi over 6. So we know that the difference between alpha and this angle argument of Z3 minus Z2 is pi over 3. Because pi over 6 minus pi over 6 is, this 2 becomes plus and then 2 pi over 3, which is just pi over 3. So if you subtract pi over 3 from alpha, you get the argument of P2, P3, or Z3 minus Z2. That's the solution to number A, and then number B. Find the modulus and argument of Z2 minus Z1, and then Z2 minus Z1 over Z3 minus Z2. So we know that Z2 minus Z1 is P1, P2, and then Z3 minus Z2 is P2, P3. The magnitude of these two vectors is exactly same since they are isosceles triangle. I'm gonna erase this a little so you can see this better. Okay. Since these two sides are equal in magnitude, the modulus of this Z2 minus Z1 over Z3 minus Z2 must be equal to 1. And then here, the argument of Z2, the argument of Z2 minus Z1 over Z3 minus Z1, this is same thing as Z2 minus Z1 minus Z3 minus Z1 with the properties of the polar form of complex numbers. Then we know we set Z2 minus Z1 as alpha, and then argument of Z3 minus Z1, Z2 as alpha minus pi over 3. Then this one becomes alpha minus alpha plus pi over 3. So you get rid of alphas, and the only number left over is pi over 3. This is the argument of this whole vector.